We are now moving technology at a rate of 4 times every year. 4 times every year over the course of 10 years. Incredible scaling.
What if I told you that the world of technology is advancing at a mind-blowing pace, 4 times every year? In today's video, NVIDIA's CEO reveals the secrets behind AI's incredible growth, why it's getting smarter and faster, and how it's about to change everything we know about computing. From smarter models to futuristic planning systems, you'll want to know what's coming next. And the best part? It's happening right now. Stick around until the end for exclusive insights that will blow your mind. You don't want to miss this. If you're amazed by the future of AI, don't forget to like this video, share it with your friends, and hit subscribe for more groundbreaking tech content.
Now remember, there was a time when the world, Moore's Law was 2 times every year and a half, or 10 times every 5 years, 100 times every 10 years. We are now moving technology at a rate of 4 times every year. 4 times every year over the course of 10 years. Incredible scaling. And we continue to find that AI continues to get smarter as we scale up the training size. The second thing that we've discovered recently, and this is a very big deal, after you're done training the model, of course, all of you have used ChatGPT. When you use ChatGPT, it's a one-shot. You give it a prompt. Instead of writing a program to communicate with a computer today, you write a prompt. You just talk to the computer the way you talk to a person. You describe the context. You describe what it is you're querying about. You could ask it to write a program for you. You could ask it to write a recipe for you, whatever question you would like to have. And the AI processes through a very large neural network and produces a sequence of answers, producing one word after another word. In the future, and starting with Strawberry, we realize that, of course, intelligence is not just one shot, but intelligence requires thinking. And thinking is reasoning, and maybe you're doing path planning, and maybe you're doing some simulations in your mind. You're reflecting on your own answers. And so as a result, thinking results in higher quality answers. And we've now discovered a second scaling law. And this is a scaling law at a time of inference. The longer you think, the higher quality answer you can produce. This is not illogical. This is very, very intuitive to all of us. If you were to ask me, what's my favorite Indian food, I would tell you chicken biryani, okay? And I don't have to think about that very much, and I don't have to reason about that. I just know it. And there are many things that you can ask it. Like, for example, what's NVIDIA good at? NVIDIA is good at building AI supercomputers. NVIDIA is great at building GPUs. And those are things that you know that it's encoded into your knowledge. However, there are many things that requires reasoning. For example, if I had to travel from Mumbai to California, I want to do it in a way that allows me to enjoy 4 other cities along the way. Today, I got here at 3 a.m. this morning. I got here through Denmark. And right before Denmark, I was in Orlando, Florida. And before Orlando, Florida, I was in California. That was 2 days ago. And I'm still trying to figure out what day we're in right now. But anyways, I'm happy to be here. If I were to tell it, I would like to go from California to Mumbai. I would like to do it within 3 days. And I give it all kinds of constraints about what time I'm willing to leave and able to leave, what hotels I like to stay at, so on and so forth, the people I have to meet. The number of permutations of that, of course, quite high. And so the planning of that process, coming up with an optimal plan, is very, very complicated. And so that's where thinking, reasoning, planning comes in. And the more you compute, the higher quality answer you can provide. And so we now have 2 fundamental scaling laws that is driving our technology development. First for training, and now for inference. The number of foundation model makers has more than doubled since the beginning of Hopper. There are more companies that realize that fundamental intelligence is vital to their company, and that they have to build foundation model technology. And second, the size of the models have increased by 20, 30, 40x, the amount of computation necessary to train these models because of the size of the models, but also multimodality capability, reinforcement learning capability, synthetic data generation capability. The amount of data that we use to train these models has really grown tremendously. That's one. And then the other reason, of course, is that Blackwell is also used for generating tokens at incredible speeds. And so together, all of these factors has led to the demand for Blackwell being incredibly high. let's talk about now how we're going to use this technology. The headline I thought was really good. NVIDIA is AI in India. Now, aside from the letter V, you could use NVIDIA to create the rest of that sentence, which I thought was really cool. You don't know this story, but in 1993, we had to come up with a name for our company, and the reason why we chose NVIDIA, I'll do the extreme short version. The reason why I chose NVIDIA in the end was because I really love NVIDIA sounds like a mystical place. India, NVIDIA, and sounded like a great place. And so if it turns out that computer graphics and accelerated computing didn't work out for us, we could do almost anything. And so I'm just happy it worked out. Okay, so NVIDIA in India. We have a really rich ecosystem here. The first thing that you have to realize is that in order to build an AI ecosystem in any industry or in any country, you have to start first with the ecosystem of the infrastructure. And we announced that Yotta, that ETE, Tata Communications, and our other partners are joining us to build fundamental computing infrastructure here in India. And in just 1 year's time, by the end of this year, we will have nearly 20 times more compute here in India than just a little over a year ago. That's the amount of infrastructure we're getting. So the first part of building an AI ecosystem is the AI infrastructure. Just as the first part of infrastructure for the internet ecosystem was building the infrastructure of networking. Of course, the infrastructure of networking internet consists of the personal computer, cloud, and internet itself. In the case of AI, it starts with the AI computing infrastructure.